Hi everyone. So this one's for the extra credit. This is an exercise covered in the past when we learned Doppler effect, but now we're going to extend it and learn how to calculate the frequency due to the Doppler shift. Okay? It says, a police car is driving at 70 miles per hour with its siren on, which produces sound waves with a frequency of 850 hertz. Person A is standing in front of the police vehicle as it approaches her. What frequency would person A hear? Speed of sound is 340 meters per second. Now, the first thing to notice is, as you can see in the picture, the frequency for person A, it's going to be higher than the frequency for person B. And this is just part of the Doppler effect. And notice the distance between the waves. So if the wavelength is short, then the frequency is high. Okay? Forget that. And we have the equation F just by itself is the frequency due to the Doppler effect. F naught is the original frequency. You can see it as F original. And then V by itself is just the speed of sound. V sub O is the velocity of the observer. V again, just speed of sound. And V sub S is the speed of the source which is producing the sound. For this case is the police vehicle, as you can see. And then you have to take into account these four scenarios. But for our exercises, everything that we do with Doppler effect, the observer is not moving. So we don't have to worry about these two, only V sub S, which is the source. And I already have the equations for you. As you can see, one for receding source, that is when the source of sound is moving away from us, and approaching source, that is when the source of sound is moving towards us. And for our problem, I already have a check mark because it's an approaching source. The police vehicle is approaching person A. So we're going to calculate the frequency for her, person A, okay? And we start with the given as usual. So write given. We have the velocity of the source, which is the police vehicle, 70 miles per hour. And then we have the frequency, the original frequency, 850, as you can see. So write F naught, 850 hertz. And we have the speed of sound, which is just V by itself, 340 meters per second. And just for good practice, let's write the velocity of the observer. And since she's not moving, it's just 0 meters per second. And we want frequency due to Doppler effect. If you were to continue and just substitute numbers, the answer would be incorrect. Reason being is we have the velocity of the source in miles per hour. Those are not the units we use for velocity or speed. We want meters per second. So we're going to review dimensional analysis, and I'm going to teach you the way I learned in college. I know I keep saying this is what I did in college, but that's because when I took physics in high school, I honestly did not learn any of these. That's why I became a high school physics teacher, so that you don't have to go through the same thing I did, okay? And we start this way. We write the units that we want, which are meters per second. This is our goal. Now we write the number which we want to convert, that is 70 miles per 1 hour. So we turn this speed into a ratio. Vertical line. And then notice we have miles on the top, so we need to cancel it with miles on the bottom. So we write 1 mile. And we want meters on top, so contains or has 1,609 meters. Now we have meters on top because we're going to cancel miles with miles. So check mark. And then we have hour on the bottom, so we need to cancel it with 1 hour on the top. I believe with all my heart that you know 1 hour contains 3,600 seconds or 3,600 seconds, and that is just 1 hour contains 60 minutes, 1 minute contains 60 seconds. 60 times 60 is 3,600, so 1 hour contains 3,600 seconds. We cancel this hour with this hour, and we have meters per second. Check. Now all we do is multiply all the numbers on the top and divide them by the multiplication of the numbers on the bottom. Okay? So it would look like this. 70 times 1,609 meters times 1. Divided by 1 times 1 times 3,600 seconds. So let's do that one real quick. That would be parentheses 70 times 1,609. I know I do not need to multiply times 1 because it would give me the same number, but I'm just going to do it for good practice and so that you do not get confused. Divided by parentheses 1 times 3,600. Press enter. We have a fraction. Control enter to get a number. So we have 31.286. Let's round it to 31.3. Okay. So this is equal to 31.3, and then we have the units, which are meters per second. So we extend our given by adding this number to the velocity of the source. Now we can substitute. Don't forget, this is the equation that we want, approaching source. So let's write it. F is equal to F naught, which is the original frequency, 850 hertz, times, I'm going to add the parentheses at the end. No, let's do it now. Okay. So we have speed of sound, 340 meters per second, plus velocity of the observer, which is 0 because she's not moving. Person A is not moving. Divided by parentheses speed of sound, which is 340 meters per second, minus the velocity of the source, 31.3 meters per second. And here's a dot so we don't forget we have to multiply. You could simplify because 340 plus 0 is just 340. We could make this subtraction, but let's just use this one over here. 850 times, so let's write parentheses, 340. I'm not going to add plus 0. That one's very simple. Now divided by parentheses again, 340 minus 31.3. Close this parentheses and close the second parentheses. I'm using double parentheses so that our Inspire knows 340 minus 31.3 is an operation by itself. Because if not, we would get a crazy number, okay? Press enter. We have 936. That would be the frequency, 936. And it makes sense because we said the frequency had to be higher than 850. So 936 is higher than 850. Then we can write frequency is equal to 936 hertz. Now let's go back to the exercise. And then this is why option B for this previous problem was 936. Now you believe me. Now you know I did not make that number up. It is 936. Okay, and that's it. Good luck in your test.